Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories.
Pluto didn't break the rules, we rewrote them. Have you ever stopped to think about this? The 9 planets we learned in school were never really a final scientific truth, more like a constantly edited guest list of the solar system. And on that list, one name had the most dramatic journey of all: Pluto. It was once proudly called the 9th planet, then it was quietly removed, textbooks were rewritten almost overnight. But the real story was never about it being kicked out. It was about why we thought it belonged there in the first place. And that story starts with a much bigger mystery. In the late 19th century, astronomers noticed something odd. Uranus wasn't behaving properly. According to Newton's laws, its orbit should have been predictable, clean, stable, but observations showed tiny deviations. So small you'd never notice them in daily life, but in space, those tiny errors matter. It's like driving on a highway and suddenly hitting a 1 centimeter bump. Something invisible is still influencing the motion. So scientists made a bold guess. There must be another unseen planet out there, pulling the strings. They even gave it a name, Planet X. Sounds like a hidden boss in a video game, right? So the hunt began. At Lowell Observatory in Arizona, one man became obsessed with finding it, Percival Lowell. He believed the planet existed, and even calculated where it should be. He literally drew maps of where it might appear in the sky. But he never found it. Still, he didn't give up. So the observatory started a brutally simple method, photographing the sky over and over again. Not once, not 10 times, thousands of times. Because if a planet was really there, it would slowly shift against the background stars. And then came a young man who changed everything. Clyde Tombaugh. Not a professor. Not a famous scientist, just a farm kid from Kansas who built his own telescopes. But he had something rare: extreme patience, and almost inhuman attention to detail. His job was almost mechanical. He compared 2 photographs of the night sky, taken on different days, using a blink comparison technique, flipping between images quickly. If something moved, even slightly, it might be a planet. Imagine sitting in a dark room, staring at thousands of tiny stars, day after day, repeating the same motion, like searching for a moving grain of dust in the universe. Until February 18, 1930. Between 2 plates, a tiny point of light shifted. Barely visible, but wrong enough to matter. Tombaugh realized it immediately: this could be Planet X. It was later named Pluto. The world celebrated, the solar system was finally complete. 9 planets. Clean and simple. Written into textbooks. Everything looked perfect. But in science, there are 3 dangerous words. It looks perfect. Because from the very beginning, Pluto carried a misunderstanding inside it. Humans thought they had confirmed a precise prediction, but in reality, they had just stumbled upon something real, in the wrong context. And the twist? That object turned out to be far smaller and far stranger than anyone expected. And this was only the beginning, because Pluto was about to slowly challenge the very definition of what a planet even is. Picking up right where the story left off. When Pluto was first discovered, humanity was still riding a wave of confidence. It felt like we had finally figured out the solar system. 9 planets. Clean order. Perfect lineup, like a neatly arranged set of cosmic furniture. But as the saying goes, looks can be deceiving. Because that furniture was never as stable as it seemed. In the early days, scientists made a bold assumption: Pluto might actually be quite large. Some even thought it could be Earth-sized, a rocky world just hidden in darkness. Today that sounds almost funny, like mistaking a flashlight in the distance for a lighthouse. But back then, it made sense. Because there was only one real clue: light. No spacecraft. No close-up images. No direct data. Just a blurry dot moving against the stars. So scientists did what they could. They worked backwards from gravity, estimating its mass based on how it affected other orbits. And that's where things started to drift off course. As measurement tools improved, Pluto's identity began to shrink. First, slightly smaller than Earth, then smaller than Mars, then smaller still. And when its moon Charon was discovered and used for accurate calculations, the result was almost awkward. Pluto wasn't just small. It was smaller than Earth's moon. At that point, the solar system suddenly felt a bit uncomfortable. Like discovering the new star athlete you expected is actually just a skinny transfer student from the next class. But size wasn't the only issue. It was how wrong the expectations were. In astronomy, mass is everything. It shapes gravity, orbits, even what kind of world you are. And Pluto slowly slipped into a strange category, too complex to be a small object, too weak to behave like a real planet. A true in-between case. Neither fish nor fowl, as the saying goes. And while this debate was building, another problem had already been quietly sitting in plain sight: its orbit. If the other planets were running neatly in lanes around the Sun, Pluto wasn't even on the same track. First, its orbit is extremely stretched in elongated ellipse. Sometimes it moves closer to the Sun than Neptune, sometimes it drifts far into the deep freeze of the outer system. Stand on Pluto, and the Sun wouldn't look the same twice. At times a bright lamp. At times just another star. Then there's the tilt. Most planets share a fairly flat orbital plane, but Pluto leans about 17 degrees off it. If the solar system were a vinyl record spinning smoothly, the planets would glide on its surface. Pluto, it's like a disk thrown in at an angle, refusing to align. And yet, it gets more interesting. Because Pluto and Neptune have a strange orbital relationship, their paths seem to cross, but they never actually collide. Why? A 3:2 orbital resonance. For every 3 orbits Neptune makes, Pluto makes exactly 2. It's like 2 runners on separate tracks, perfectly timed so they never bump into each other. So Pluto isn't exactly breaking the rules. It's following a deeper, hidden one. Just not one that felt intuitive at the time. And that's why scientists slowly ran out of comfortable words to describe it. Too small, too strange, too irregular. Yet still orbiting the Sun. A world that didn't fit, but also couldn't be ignored. And that mismatch would eventually force humanity to rewrite what we even mean by the word planet. Before Pluto's identity crisis fully exploded, something important had already shifted behind the scenes. Humans started to realize a strange possibility: Pluto might not be alone. In the late 20th century, especially after the 1990s, telescope technology took a huge leap forward. CCD imaging, deep sky surveys, long exposure observations. Suddenly, the outer solar system wasn't invisible anymore. And what they found changed the map. For a long time, there was an unconscious assumption in astronomy: beyond Pluto, things basically ended. A neat edge to the solar system. A clean boundary, easy. But nature doesn't care about neat. In 1992, astronomers found something unexpected: an object called 1992 QB1. Small, dim, unimpressive. But its meaning was huge. Because it proved something simple and unsettling: Pluto was not alone. It wasn't sitting at the edge of the solar system. It was sitting inside a crowd. That's when a new idea was born: the Kuiper Belt. A vast region beyond Neptune filled with icy bodies, rocky fragments, frozen leftovers of planetary formation. Not planets, not stars, just countless small worlds. And Pluto, just one of the more noticeable ones. As the saying goes, one swallow doesn't make a summer. And Pluto was no longer a singular exception. Then came the real turning point. In 2005, astronomers discovered a new object, Eris. And it immediately made things uncomfortable. Because depending on how you calculated it, Eris might actually be more massive than Pluto. Now the question became unavoidable. If Pluto is the 9th planet, what is Eris, 10th, 11th? Or planet 9.5? The solar system's official list started to fall apart. And scientists realized something awkward: they weren't just finding more planets. They were finding more Pluto-like things. So Pluto stopped being unique. It was no longer the lone 9th planet at the edge of everything. It looked more like the first discovered example of a whole population. A representative, not a ruler. And once a unique case becomes a common type, classification stops being stable. That pressure finally reached a breaking point in 2006. The International Astronomical Union met in Prague to settle it. On paper, it was just another scientific meeting. In reality, it was about to rewrite the solar system's official identity card. The question was simple, but dangerous. What is a planet? After intense debate, a new definition was approved. A planet must orbit the Sun, be round due to its own gravity, and most importantly, clear its orbital neighborhood. And that third rule changed everything. Pluto passed the first two but failed the third completely. Its orbit is filled with Kuiper belt objects. It never cleans out its path. So the conclusion was direct. Pluto was no longer classified as a planet. From that moment, the solar system officially had 8 planets. Pluto became a dwarf planet. The reaction wasn't simple. Some scientists saw it as necessary cleanup, others felt like history had been rewritten in real time. And among the public, it felt almost personal, like a school textbook quietly deleting a childhood memory. But here's the twist. Pluto didn't become less interesting. It became more complicated. Because right after the reclassification, another detail stood out. Pluto's largest moon, Charon, is enormous relative to it. So large that the system doesn't behave like a normal planet and satellite setup. Their masses are so close that their shared center of gravity actually lies outside Pluto itself. Meaning they don't orbit in a simple hierarchy. They orbit each other around a shared point. Not planet and moon. More like a paired system. If traditional planets are like someone walking a dog, Pluto and Charon are more like 2 dancers spinning in sync, holding each other's rhythm. Hard to say who leads. Hard to say who follows. So a new idea emerged. Pluto isn't just a single object. It's a system. And in a strange way, even after being downgraded, it didn't become ordinary at all. It simply changed category from a lonely planet to the entrance of a much more complex world. When Pluto was officially downgraded, the story didn't slow down. It sped up. Because in the same year it lost its planetary status, something else quietly left Earth. A spacecraft built for obsession. New Horizons. Launched in January 2006, its mission was simple on paper and almost insane in reality: reach Pluto. And as the saying goes, good things come to those who wait. Well, this one took patience to a whole new level. Because Pluto is not just far. It's ridiculously far. Even traveling at record-breaking speed, New Horizons needed about 9 years to get there. No stops. No detours. No quick check-ins. Just straight-line persistence through darkness. A lone messenger heading toward a destination most people had already stopped thinking about. Pluto slowly stopped being a place in public imagination and became an idea. Until July 14, 2015. That's when the idea finally became real again. New Horizons flew past Pluto for the first time in history. Not a blurry dot anymore, not a distant light. A surface. A world. Up close. And what it found wasn't simple at all. Pluto wasn't a dead gray ice ball. It had landscapes, structure, personality, vast plains, sharp contrasts, frozen geology everywhere. And then there was the famous heart-shaped region, Sputnik Planitia. A smooth, bright basin of flowing nitrogen ice, almost like it had been carved with intention. Around it, towering mountains. Not ice like you'd imagine on Earth. At Pluto's temperatures, water ice behaves like rock, hard, rigid, permanent. Some peaks rise kilometers high. At that moment, you're no longer thinking outer solar system. You're thinking, this looks like another world entirely. Then came the atmosphere. Thin, fragile, but real. Mostly nitrogen, with traces of methane and carbon monoxide. And then the surprise. A blue haze. Not Earth-like blue skies, not warmth. Not air you'd breathe. But a cold, ghostly glow created when sunlight scatters through a razor-thin atmosphere. A frozen world, with a sky. And after this flyby, the scientific view shifted. Pluto was no longer just a distant ice object at the edge of the system. It looked active, structured, complex, and maybe even alive in a geological sense. Not metaphorically. Literally changing. Because when data came back, scientists noticed something strange. Parts of Pluto's surface didn't look ancient. They looked new. Especially in Sputnik Planitia, where the surface appeared surprisingly young on geological timescales. That raised a bold idea: internal activity. And even something more surprising: cryovolcanism. Ice volcanoes. Not lava. Not fire, but water, nitrogen, methane erupting as slushy material, then freezing instantly and reshaping the surface. It sounds like nature telling a cold joke, but it's real. And it raises a bigger question. Where is the heat coming from? Because something inside Pluto must still be working. Maybe radioactive decay. Maybe leftover formation energy slowly leaking out. Whatever the source, it changed Pluto's identity again. From a frozen relic to a slowly active ice world. Some models even suggest a hidden subsurface ocean, or at least pockets of liquid movement beneath the crust. So Pluto didn't become dead. It became quiet but not still, like a breath you can barely see. And this is where human perception flipped again. First, too small to be a planet, then, too complex to be a dead world. And all of this was revealed by one brief encounter. New Horizons didn't stop, didn't orbit, didn't return. It simply passed by for a few hours. But in that short window, humanity finally saw Pluto not as an idea, but as a living, changing world at the edge of everything we know. As the saying goes, sometimes you only need a moment to change everything. After the flyby of Pluto, one thing became crystal clear: this was not a dead, frozen ice ball. And its atmosphere? Far more complicated than anyone expected. Because Pluto completely breaks a basic intuition about planets. We imagine worlds with stable skies, stable weather, stable rules, but Pluto doesn't play by that idea. Its atmosphere literally appears and disappears. Sounds impossible, but that's what the data shows. Mostly nitrogen, with traces of methane and carbon monoxide. It's incredibly sensitive to temperature. When Pluto drifts farther from the Sun, everything freezes, the atmosphere collapses and falls back to the surface like snow. But when it moves closer again, the ice turns directly into gas, and the atmosphere rises back up. So Pluto doesn't really have a permanent atmosphere. It has a cycle. A slow, extreme version of breathing. Inhale, atmosphere forms; exhale, atmosphere collapses. But this breath doesn't take seconds or days. It takes 248 years. As the saying goes, slow and steady changes everything. And standing on Pluto, the sky itself would not be consistent. In one era, there is an atmosphere above you. In another, there is almost none. Its weather system is less like Earth's, and more like geological time pretending to be weather. Behind this strange behavior is simple orbital physics. Pluto's orbit is highly elliptical, meaning its distance from the Sun changes dramatically. At its closest, it's just over 30 astronomical units away. At its farthest, more than 49. That difference is enormous in a world this cold. Even a tiny temperature shift is enough to turn solid nitrogen into gas. So the entire atmosphere constantly resets itself. And when New Horizons arrived, this wasn't just confirmed, it became clearer than ever. Pluto's atmosphere wasn't a thin static shell. It was a dynamic exchange system between surface and space. Multiple layers of haze also appeared at different altitudes. These hazes are formed when methane and other organic molecules are broken apart by ultraviolet sunlight, then recombine into extremely fine particles. The result is surprising: a faint blue gradient in the sky. A frozen world, with color. And that changed how scientists saw it. Pluto was no longer just a leftover from the outer solar system. It looked like a slow, evolving system. And that leads to a bigger question. If Pluto is dynamic, has an atmosphere, and even shows geological activity, what exactly is it? That question eventually exploded into one of the biggest debates in modern astronomy. What even counts as a planet? Before Pluto, the answer felt simple: anything orbiting the Sun was a planet. But that definition started to fall apart once Pluto entered the picture. Because it wasn't alone. The Kuiper belt turned out to be full of icy bodies, some nearly Pluto's size or even larger. So in 2006, the International Astronomical Union had to step in and redefine the word planet. 3 rules were introduced. First, it must orbit the Sun. Second, it must be round due to its own gravity. A third, and the decisive one, it must clear its orbital neighborhood. Pluto passed the first 2 easily, but failed the third completely. Its orbit is crowded with Kuiper belt objects. It never dominates its path. So the conclusion was clear. Pluto was no longer a planet. It became a dwarf planet. And here's the key point: Pluto didn't really change. The definition did. As history often shows, classifications are not nature itself, they are human tools. Like the saying goes, the map is not the territory. In biology, birds were once grouped differently before being reclassified. In astronomy, planets went through the same evolution. Pluto sits right on the edge of that system. Too complex for a small body, too irregular for a classic planet, but not dominant enough to qualify under the new rule. It became a pressure point in the classification system. And when enough Kuiper belt objects were discovered, that pressure was released by rewriting the definition itself. In a sense, Pluto was not demoted. It triggered a correction, a realization that the word planet was never as precise as people thought. And when a system can't contain reality anymore, it's not reality that changes. It's the rules that have to move. So Pluto's story isn't just about lost ninth planet. It's about something deeper. The moment humanity had to redraw its own boundaries of understanding. Talking about what Pluto did wrong is actually a bit unfair. Because the truth is simple, it didn't suddenly become unqualified, the rules changed, and only then did it start to look out of place. In other words, Pluto didn't really change. We changed how we define it. And as the saying goes, don't move the goalposts mid-game. But that's exactly what happened here. This isn't unusual in science. Ceres was once considered a planet too, before being reclassified. Even the idea of planet itself has never been fixed. Newton's laws weren't wrong, they were just incomplete at larger scales. Science isn't about finding final answers. It's about constantly refining older ones. And Pluto happened to sit right on that boundary. It has an atmosphere. It has moons. It even shows signs of geological activity. But it cannot clear its orbital neighborhood. So the real issue wasn't whether Pluto was good enough. It was that the definition of planet stopped being large enough to contain objects like it. The 2006 reclassification wasn't really a verdict on Pluto. It was an attempt to tidy up the entire solar system's taxonomy. But every cleanup comes with a cost. We imposed a cleaner rule on a far messier reality. And Pluto just happened to be standing right on the line where that rule was redrawn. And the story doesn't even end there. After flying past Pluto, New Horizons kept going outward, deeper into the edge of the solar system. Beyond Pluto, there is no clear border, just a thinning population of icy objects fading into the dark. Farther still lies the hypothetical Oort cloud, a vast and distant region we've never directly seen. And some scientists still wonder, what if there are more Pluto-like worlds out there, just waiting to be discovered? In that sense, Pluto is not an endpoint. It's a clue. A reminder that the solar system is still being mapped, not finished. And that leads to a more uncomfortable question. Are we looking at the true structure of the solar system, or just the best version we're able to explain so far?
The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.